Visit us at Eduvvo. Thank you for calling Eduvvo.
Instead of having our column with that single child scroll view, there is another widget baked into Flutter that we can use to ensure that we automatically have a scrollable column or row, because it's such a common pattern that you need multiple widgets next to each other or on top of each other or above each other, and that list should be scrollable, and a column and a row by default is not scrollable. So of course you could always wrap your columns and rows with single child scroll view, but as I said, Flutter has a shortcut here. Instead of manually adding that single child scroll view, let's get rid of it here in the transaction list widget. And instead of that, let's use, instead of the column, a list view widget. List view is a widget provided by Flutter, which is in the end, by default, a column with a single child scroll view, you could say. On the list view, you can set a bunch of things. Most of them are relatively advanced and rarely needed, but you can also set a scroll direction in case you need a row instead of a column, a scrollable row. With that, if you save it, now we'll have the same behavior as before, as I can quickly prove if I enter items here. This is a scrollable list in that container which we defined here. Now, also important, if I remove that container here in my transaction list widget, now you see no transactions are shown and we actually get an error here. It's a pretty long error message and it can be complicated to read. In the end, the problem is that the vertical viewport was given an unbounded height. And this might sound cryptic, but what it means is that list view is in the end a widget which, yes, is a column with a scroll view. But what it means in the end is that list view is basically a widget that has an infinite height. Unlike a column which takes all the height it can get on the given screen, a list view does not have a fixed height. It can't have a fixed height because it's scrollable. There are items that are currently not on the screen, and therefore the height where all the items have to fit in the end has to be infinite, because it has to be larger than just the screen size. Otherwise, the items that are there and just aren't on the screen at the moment wouldn't be there, right? So there are items below the screen or above the screen, depending on where you scrolled, and these items are also part of the list view. Therefore, its height is higher than the screen height. It's actually infinite. The problem with an infinite height just is, if you throw it into your page like this, Flutter doesn't know how to size that list view. Of course, to you as a human, it's obvious. It should take the remaining space here, right? But that's not how Flutter works. It needs clearer instructions than that. So you need to give it some constraints, some settings on how much height it should take. And previously, with that container, we had that. If you have a container around your list view, you have exactly that kind of constraint you need. You're telling Flutter, add that list view, please. And Flutter has a look at its parent and it finds out, oh, my parent has a height of 300. Okay, I will take 300 as a height for the list view. Without that container, the parent here of the list view is, since we use transaction list here in user transactions, is in the end that column. And a column by default takes all the height it can get. So the problem with that, of course, is if we have something that takes all the height it can get, and then we have something that has an infinite height, if we combine these two, we have a problem, because as much as I can get and I know no limits is a bad combination. So here we need some wrapper that defines a height so that Flutter knows how big that list view actually should be, how high it should be in this case. But with that, using a list view is the better alternative to using a column with a single child scroll view because, well, it's in the end shorter. And in addition, you get a couple of other optimizations and improvements which the list view has baked in. We learned about the list view. There are actually two kinds of list views, or two ways of using it, I should say. The list view widget can be used as we used it by passing a children argument to its constructor, and then you have a list of child widgets. The alternative way of using the list view is to use the builder constructor it offers you. So that's an extra constructor on the list view class, which also gives you a list view, but a list view that works differently. Now let's first of all have a look at the left case. There we have our child widgets, and as you learned, a list view in the end is like a column with a single child scroll view around it. And therefore it's able to have more items than we have space on the screen because it has an infinite height or width. The list view builder generally works similarly, but there we have no wrapping single child scroll view in that sense. But instead, here we have some optimizations put in place by Flutter. To be precise, the list view builder in the end only renders the widgets that are visible. And that's a difference to the scenario on the left here. With list view, where you pass your children as an argument, all widgets that are part of the list view are rendered even if they're off screen. Now, for short lists, that's no problem, but for very large lists, that means that you consume a lot of memory, a lot of performance for items that aren't even visible. And if you then scroll such a long list, you can have lags and bad performance because Flutter needs to manage all these items in memory, even though you might not be seeing them right now. You can't interact with them right now. Still, Flutter needs to maintain them all in memory. The idea with the list view builder is that Flutter actually gets rid of all the items which are currently not visible and only shows you what's visible. So the parts that are not on the screen are not loaded or not rendered, to be precise. And this therefore is the solution and the approach you should use for very long lists or for lists where you don't know how many items will be on it, so that for longer lists you don't run into performance issues and lags. Now, it is worth noting that the list view builder, of course, has a certain threshold, so it doesn't instantly remove every item that's not on the screen anymore. It waits until this is a little distance away, so until you scrolled a bit before it actually removes that. And the list view on the left here, where you pass children, will actually also get rid of elements that are outside of the current viewport or beyond a certain threshold. But unlike list view builder on the right, it has less optimizations in place. And unlike list view builder, it actually does create all items that are in it initially and does not create them lazily when they're needed, but instead it just has a limited amount of optimization. So you don't want to use that for very long lists or lists where you don't know in advance how many items you'll have, and potentially you might have a lot. In such cases, you might want to use list view builder instead to improve performance. So let's have a look at that list view builder then. We can easily transform our existing list to such a dynamically loaded and rendered list by using list view builder instead of list view, but now we need to pass different arguments here. The builder method requires an item builder argument. That's a must-have. You must provide the item builder. Now, item builder, in turn, takes a function that will give us a context. We get that automatically. Flutter manages that for us. Context is this meta object with which we haven't really worked thus far, which holds information about the position of the widget in the widget tree. And int, it gives us a number of type int. And that actually will be the index of the item we're currently building. But step by step, item builder takes a function. So you need to provide a function here, either a named function or, as I'm doing it here, an anonymous function. Then this function, as I just mentioned, receives a context, and I will name this CTX. You can give this any name you want, but the value of this argument will be build context. Because this function here is not called by you, so it's not your job to provide these arguments, it's called by Flutter, because it calls this builder function here for every new item it wants to render on the screen, for every new list item in the end. And it gives us a context, which we don't need here, but still we get it. And it gives us an index of that item. So is it the first item, the second item, the third item of the items it should render? That's what we get here. Now, what you can't provide to the builder constructor is your children thing here. Instead, what you need to provide is the item count argument. And that defines how many items should be built. In our case here, that would be the length of our transactions list. If we have 2 transactions, we want to build 2 items, right? So we pass transactions.length, which gives us the number of items in our transactions list. Now Flutter knows that it should execute this function here twice if we have 2 items, or as often as we have items in transactions. And now in here, we have to return a widget that is built for this item we're currently looking at. So a widget that is built for the first item, for the second item, and the third item, and so on. The item I want to build here, of course, is my card here, so I can actually grab this entire return statement here, all the way up here, and replace this return statement with it, so that I return my card inside of that builder method here. The problem now just is, in there, I previously got my transaction, because previously we mapped our list of transactions to a list of widgets. This approach does now not work anymore, because now the builder instead simply takes a number of items, not the list itself, just a number of items, and then repeats this function here, this builder function, for every item. In order to now get access to the different transactions, we can simply replace tx here with transactions, which is our overall transactions list. And there, with the square bracket syntax, we can access a specific index. And here, it's convenient, and of course, not a surprise and not happening by accident, that Flutter gives us the index as a second argument in this function it calls for the item it tries to create. So it gives us 0 for the first element it tries to create, 1 for the second element, and so on. And therefore, we can use this index here to access the first transaction, the second transaction, and so on, depending on which item is getting built. And this is all managed by Flutter. So now we use transactions index instead of tx here. And with that, if we save this, we got our transactions here, but now built with the help of the builder. And that, of course, is pretty nice, because now, here, of course, we don't really see that or feel that, but now we have a list that also has a great performance for a lot of items. So now this is the solution you should use for very long lists. For lists where you know how many items you have, and it'll only be 6 or 7, then using listview.builder is perfectly fine. But for long lists or lists where you don't know in advance how many items you'll have, consider using listview.builder to get the best possible performance.